Here is the problem that we're going to use in our Excel example. Here we have a Omni Powers bar scenario where we have sales of Omni Power bar, and we want to see what effect the price and promotion have on the sales of the Omni bar. So similar to the example in PowerPoint file that we just looked at. So here we are collecting data on monthly sales, okay, per month, the number of bars sold per month, and for each of those months we are looking at what is the price that we are charging per bar. Okay, except one is the price of an Omni bar, and it is in cents. So the price of the Omni bar is in cents. We need to keep that at the back of our mind when we get to this, the interpretation part of the slope coefficients. Now the second independent variable is monthly budget for in-store promotion or promotional expenditure. So again, on the monthly basis. Okay, now we have a random sample of 34 stores. So here we are taking a snapshot of a random sample of 34 stores. So since this is not a time series, so the autocorrelation problem may not be relevant here, but we will get to that later. So we have 34 observations, and we want a regression. We want to analyze a regression model between number of bars sold per month, that as the dependent variable y, and price per bar and promotional expenditure as the two independent variables. So let's now go to Excel. Now here is the data of sales, price and promotion. Let's define the variables first. So y is the dependent variable. That's the number of Omni bars sold in a month. X sub 1 is price of an Omni bar, and that price is in cents. And then we have monthly in-store promotional expenditure, and that is in dollars. Now the regression model that we want to analyze is y-intercept beta sub 0 plus beta sub 1 x sub 1 plus beta sub 2 x sub 2, and then an error term. So this means the expected value of y, or expected value is another way of saying mean of y. So mu sub y is, you drop the error part, and what remains is your mean of y given a pair of values for x sub 1 and x sub 2. Now we want to develop multiple regression equation, and that is estimates for the beta coefficients. So something like that. Now we are not going to use any formulas, so all we are going to do is to use Excel data analysis. So let's move to the data area. So we have the y values here. The x values are these two. Store is simply an identifier. We're not going to use that in any of our analysis. So go to data analysis, regression. Okay, now y range is sales, and the x range now is the two columns, like that. Okay, so now we have included labels in the first row, so check labels, and then let's select the output range as that one. Okay. If you wanted the confidence interval to be other than 95%, then you can change that here. And if you're satisfied with 95%, then just leave it as 95%. Okay. And if you wanted any residual output so that you can do residual analysis, then you can select those, but we will not select any right now. But when we get to the assumptions topic, then we will run the regression again, and we will generate the residuals that we want. So for the moment, this is sufficient, so click OK. And we have the output. Okay. Now the E plus 07 that you see, just scientific notation, the column width is not large enough for it to display the entire value. So if you increase the column width, then you'll see that the scientific notation is gone. And here again, this is scientific notation. If you change it to a percentage with certain decimal places, then you'll see that you can understand the number better. So regression, sum of squares, residual, which is the error, sum of squares and total, and then your mean square, then you have the f value, okay, and then here are the coefficients. Okay, let's keep 2 decimal places. Okay, so here are the coefficients. So we can now write the regression equation as the y-intercept minus 53.22 x sub 1, the price of the omnibar, plus 3.61 x sub 2. So that's what our regression equation is going to look like. So now we can interpret the coefficients, the 2 slope coefficients here. The first one is b sub 1 is minus 53.22 x sub 1. So that means if x sub 1 goes up by 1, x sub 1 is price in cents. So if the price increases by 1 cent, this is what will happen to number of units sold per month. Okay, that is minus 53.22 is what will happen to y. Our estimated sales will go down by 53.22. And we have to, in multiple regression, we have to add a caveat to this interpretation, and that is you have to say that the other independent variables remain the same. So here we are assuming, given that the other independent variable, which in our case is the promotional expenditure, given the same promotional expenditure, if the price of the omnibar goes up by 1 cent, then the number of omnibars sold per month is estimated to go down by 53.22 units. So this caveat is extremely important. If you fail to mention the caveat, then that is not a complete and proper interpretation. So make sure that you don't skip that part. Now b sub 2 is 3.61. So here, given the same price, the other independent variable is x sub 1, and that is price per bar. Given the price per bar is the same, at the same price per bar, if your in-store promotional expenditure goes up by, here x sub 2 is in dollars, so it goes up by $1, then this is what will happen to number of units sold per month. The units sold per month is estimated to go up by 3.61. So given the same price, per unit, the number of omnibars sold per month is estimated to go up by 3.61 on the average. Don't round this. There is no need for rounding. Okay, this is our estimate. Okay, for each additional dollar spent on in-store promotion. So now let's look at how to use this in predicting Y. Okay, predict the mean sales of omnibar for a store charging 79 cents per bar, okay, $0.79. So x sub 1 value is 79, okay, and spending $400 in promotional expenditure. So 400, this one is in dollars. So let's assemble the b sub 0, b sub 1, b sub 2 values here. So that comes from over there. Now since it is in a column, so we can copy this, put the border back. So then we have b sub 0 plus b sub 1 times x sub 1 plus b sub 2 times x sub 2. So that will give us our estimated sales per month if we set the price at 79 cents per bar and spend $400 on in-store promotional expense.